All right, I'm back. We are on page 304. We're going to keep going. We know the product rule. We know the quotient rule. Product rule, first derivative of the second plus second derivative of the first. Quotient rule, bottom derivative of the top minus top derivative of the bottom, all over the bottom squared. So if you say them a lot, you will know them faster. This page is more doing than like learning new things. So it's kind of practice. So if you think you can do this on your own, go ahead and do that. If you don't, feel free to watch. I'm going to go through and do all the problems as I've been doing. So either thanks for staying or congrats on having mastered all this material. Either way, let's do this. So A, find but do not simplify f prime. So this looks annoying. First of all, I'm going to rewrite it because I'm not going to distribute because that's insanity because it says not to simplify the derivative anyway. But that second factor there has like a lot of issues. Not a lot of issues. It's just like it's not written in a way that's easy to take the derivative of. So at x squared. Radicals are terrible. Rewrite them as rational exponents. So minus x to the 1/2. And then 2 over x, it's better to rewrite that also with a negative exponent because then you can just power rule your way through it. 2x to the negative first. Okay, so what do we got? We got, what's my color scheme? We have a first function and we have a second function. So we're going to go first derivative of the second plus second derivative of the first. First derivative of the second plus second derivative of the first. All right, so f prime of x. First, 2x to the fourth minus 3x plus 5. Derivative of the second, 2x minus 1/2 x to the negative 1/2 minus 2. Ooh, look, it changed that to like a super nice thing there. Also, there's like a bubble trying to blow things up. I don't know what that's about. 2x to the negative second. First derivative of the second. Plus second, which is x squared minus x to the 1/2 plus 2x to the negative first. Derivative of the first. So that'll be 8x. Let me just make sure I have that right. Yeah. 8x cubed minus 3. There you go. Find but do not evaluate. That's like classic Calc AB, Calc BC, like the question you want to see. Set up but do not evaluate. Here, find but do not simplify. That's great. So when we did this, it was first derivative of the second plus second derivative of the first. Or, because I'm changing highlighter, first derivative of the second plus second derivative of the first. Okay, so we got that. So now find the slope of the line. So the slope of the line is just the value of the derivative. So let's find f prime of 1. Why is 1 so popular? Because it's not a joke. That sounds like the setup for a joke. It's so easy to evaluate things, right? The only 1, -1, 0, you're gonna see those all the time because like they're the easiest things to sub in. You can't sub in 0 here. It's not in the domain, first of all, from the original, and then clearly not differentiable there because if you're not, if there is no point, you can't have a slope. But anyway, let's sub in here. So I'm gonna have to like scroll back and forth to actually see what's happening. So 2 minus 3 plus 5, so that's 4. 2 minus 1/2 minus 2, so just minus 1/2 plus 1 minus 1, 0 plus 2, and then 8 minus 3, it's 5. Okay, so I think the slope is 10, I think it's just 8. That's weird. All right, compare your answer to your calculator's answer. I like that question. Let's switch over to a calculator. And I'm going to put in a new problem. Okay, so new problem means that this still lives here. If I press the var key here, I still have everything defined. If I click over here and I press the var key, nothing's defined because it's a new problem, right? Like the name of a function doesn't carry through to every function you're ever going to deal with, every problem you're ever going to deal with. 2x to the fourth minus 3x plus 5. And then x squared minus the square root of x. You should use the template, and then 2 over x. Okay, so I want to find the derivative at a point. So I'm going to do menu for 2. X is the variable. I want x equal 1. And then my function is named f of x, and I get 8. All right, it's probably giving me the warning about domain. That happens a lot with derivatives. Domain of result might be larger than domain of the input. You have to watch out for that. The calculator knows that it did some sketchy things, and it's like letting you know that. It's kind of warning you. The next, I need to write the equation of the tangent line, so I'm just gonna like cheat here and get f of 1 is also 8, so that's good. Let's go back to the notes. So let's indicate that we checked, I guess. I'm gonna put a check mark here, right? So compare your answer to your calculators. Check, same answer. All right, so we found f prime of 1 is 8. We also know that f of 1 is 8 because we cheated and used the calculator, but you could go up here. You get 2 minus 3 is -1 plus 5 is 4, and then times 2. So yeah, 8. Okay, tangent line. Tan line. Y minus 8 equals 8 quantity x minus 1. I would never expand that. Eventually, when we start practicing for the AP exam, I'm going to tell you, frequently they do write the answers to equations of tangent lines in standard form, which is so annoying. It's like ax plus by equals c. That's the only time I would expand, is when it's multiple choice and I have to match multiple choice. Let's see this next question. Find the derivative of this thing. Simplify and find where f prime equals 0. All right, so do I still need to color code? I kind of don't think so, so I'm going to kind of not. We'll see how it goes. All right, bottom, because it's quotient rule, derivative of the top, minus top, derivative of the bottom, all over the bottom squared. Okay, so bottom derivative of the top minus top derivative of the bottom, all over the bottom squared. Simplify. All right, so there's definitely a 2x that I can take out of everything there. And then what do we have? We have x squared plus 1 left over. Wait, why'd I close that parenthesis? Minus x squared plus 2, right? Don't forget to distribute the negative. That's why we're using so many parentheses. And then over x squared plus 1 squared. Okay, and then this is going to simplify to 2 plus 1 is 3, x squared minus x squared gone, so actually it's 6x over the quantity x squared plus 1 squared. Okay, so that's f prime. Find where f prime of x equals 0. So, whoa, where are we going? Okay, f prime of x equals 0 would mean that 6x equals 0, which would mean x equals 0. All right, what use is that? Well, I mean, we're done with the problem. That's what it said to do. Find where f prime equals 0. But what if we did a sign chart? Should I, let's move this. It's in the way. Okay, so sign chart, right? So here we go. I'm gonna put 0 on it. So what I was checking there when I like kind of like zoomed over here, I was looking to see if the original function had any discontinuities, because if there are, you want to put those on your sign chart as well, because weird stuff can happen at discontinuities, and that's basically the reason we do that. But there were none. So this is a chart for f prime. So to the left of 0, like negative a billion, I get a negative divided by a positive, so it's negative overall. And then to the right of 0, like at a billion, I get a positive over a positive. So maybe I should make plus signs. Positive over a positive. So I know that f decreases and then increases, which is one of the things you get out of this, right? So I think this function has a relative minimum at x equals 0. And you know what we should probably do? Let's take a look on the calculator. So let's go here. I'm gonna insert a new problem, because new, right? New problem, graph page. So I'm just gonna graph the function and see if it has a minimum at 0, which I think it will, x squared. All of my work indicates there should be a minimum at 0. Look at that. There is a minimum. That's the place where the function changes from decreasing to increasing. Our sign chart told us that. Being able to read a sign chart, create a sign chart, is like a superpower as far as calculus is concerned. And it's free, so you should develop that power. That's like, do you want to be a superhero? Sure, be a sign chart superhero if you can. All right, let's see. Can I do, all right, I'm gonna do both of these. So find the derivative of this, write your answer as a single fraction. this is, it's sort of a trick question depending on how you look at it, right? It looks like you have a product for that first thing, so product rule, quotient for the second thing, so quotient rule, but why would you not just rewrite this thing? So that's what I'm going to do. I'm going to rewrite this as y equals x to the 3/2. X to the first times x to the 1/2 is x to the 1 plus 1/2, x to the 3/2, plus 3x over x cubed is 3 over x squared. I'm going to write it as 3x to the negative second. Okay. Sometimes rewriting is like the key to doing it. So I could say y prime, but I prefer dy dx. Y is the dependent variable, x is the independent variable. That's why it's dy dx. 3/2 x to the 1/2 minus 6x to the negative third. Okay, how do I simplify this? Well, make everything that can be a fraction, then look at your denominators, right? So 2 and x cubed. So here, I need a x cubed over x cubed, and here I need a 2 over 2. So I'm going to end up with 3x to the 6/2 and 1/2 is 7/2 minus 12 all over 2x cubed. So I think that that is dy dx. And I think what I should do is I should check it on the calculator to see if that is true. So let's do that. Back to the calculator. And new problem, I suppose. Okay, so if, let's just straight find the derivative, right? Derivative with respect to x of, should I do, I'm going to do the original, just, you know, so x times the square root of x. Not optional to put that multiplication sign there. If you don't do it, it thinks there's like a weird function called x sqrt, and it won't do anything. But you see, as soon as I put that in, it goes from, right now, sqrt is italicized, multiplication becomes justified, and that means that it's a built-in function, plus 3x over x cubed with respect to x, enter. Okay, so what's happening here? So it didn't get a common denominator, and that's kind of annoying. What we can do is if you go into algebra, and fraction tools is option 9, common denominator, or you can type com denom, which I like to do, of this, there. I get 3x to the 7/2 minus 12 over 2x cubed. Nailed it. Also, we learned, if we didn't know about it, common denominator. So that's useful. And there's one more question on the page, and I'm just going to do it. I know the video is probably running long. I don't know. Every time I think it's running long, I'm in like the 15-minute range, which is like, I don't know. Is that too long? Maybe, but do you have the option to pause, go get a beverage, take a nap, take a rest, and come back? You do have that. So like, all right, let's find this. dy dx. All right, I see a product, so I'm going to use product rule. Product rule first, derivative of the second, plus second, and derivative of the first. Okay, and I'm supposed to simplify this, and there's like nothing good that can be taken out of this. So here we go, I guess. 84x to the 4th. So plus 4x squared minus 21x squared minus 17x squared minus 1. All right, so that was 4 times 21, 84. And then 4 times 1, negative 21 is negative 17 and minus 1. All right. But it's like if I did it wrong, I was probably just going to get it wrong when I checked it anyway. I don't know. It happens. All right. One thing you could try like plugging in a value like x equals 2 and see if like your original and your reduced thing is the same. It's like not a bad idea. X equals, no, I was going to suggest 1/2, but I do not suggest that. Here, 7 times 8 is by far my least favorite like basic multiplication fact. I don't really know why. I think I like memorized it wrong maybe when I was little and like have never gotten over that. So this I think is 56x to the 4th plus 8x squared. I hope I didn't get that wrong, but you never know. 90, 140 x to the, what is happening there? X to the 4th minus 9x squared minus 1. Whoo! Okay, I'm just going to do it. I'm going to check it on the calculator just to see. And if I got it wrong, we'll end this video struggling to fix it. So what do I want? I want the derivative with respect to x of the quantity 4x squared minus 1. Might it have been a better idea to expand first and just power rule? Like maybe? That's always a tough call. 140x to the fourth minus 9x squared minus 1. Nailed it. All right, so I am going to switch back to the notes because we like to end on the notes, and then send it over to the next video. All right, there we go. So we got it. A lot of stuff on this page. No real well, I mean, you're always learning. More like practice, getting better at things we already knew how to do. So I hope you found this helpful, and I will see you in the next video. So see you there.